Bismillahirrahmanirrahim. Assalamu alaikum. Yesterday I wasn't able to stream because of network connectivity issues here. So today hopefully we will go over this chapter very quickly and finish it in time. I think our current pace is very slow, so we need to pick it up. So where were we? Yeah, we were doing this obfuscation machine exercise where we were trying to develop an encode function that encodes a specific string into another format using some criteria defined here, and then we also define a decode function. Okay, so where were we? Yeah, I guess we were here define encode letter. So we'll define a function named encode letter which takes a string as input or s as the only argument, and then in the define or in the let block we define a binding for the symbol code, just like by using math.power on the integer result of the first character in the array. So we take the first character in the provided string, convert it into an integer, its ASCII representation, and then take the power with respect to 2 and store the result in the code symbol. And yeah, I should have used square bracket here. Yep. And then we can use it inside our expressions. Here I am converting, for example, this could be a double, I guess, math.power would return, I guess it should return integer. I will find out. For example, if I do math.power on 2 and 3, then yeah, math.power returns a double. So we first have to convert it into an integer, and then we transform that integer back into a string representation. So it would probably, yeah, it would just return the number as a string. For example, if I call the encode letter on Adam, then it would first in the character array S, it would take the first character, which is A, convert it into its integer representation, which is 9409. For example, we can check it just like that. Okay, it's not 9409, yeah, it's 97, sorry, it's 97, and then we take the power of it, 97 power 2 math power 97 and 2, so it's 9409. We convert it into an integer here, and then we return a string representation of that. Okay, now we can create the encode function, which uses Clojure.string replace as well as our encode letter function. Okay, so now we create this define encode letter just encodes a single letter or character, and now we want to encode the whole string. So here we pass it a string or s as an argument, and then we define or we replace s and all the characters. W means all the characters, letters. This is our regular expression we're defining here, all the expressions, and we call the encode letter on it. So it would call the encode letter on each and every character or letter in S and return it. So now if we type encode Adam, so 9409 is A, 9409 is A, then this is probably D, this is 9, this is D, and this is A, and this is M. So it is encoding it fine. It seems to work, but the resulting string will be hard to decode without being able to identify each letter individually. Yeah, we need to add a separator here as well. For example, if we want to decode it, we don't know 9409. For example, here I was confusing, it was confusing for me as well, because 9409 is 4 digits long. This is also 4 digits long, and I was expecting this to be 4 digits long as well, but it was 5 digits. So we have no real way to specify, easy way to specify how many digits represent a character. So one solution is to add a symbol. For example, here 9409, and then I include a pound symbol or any other symbol here to indicate that yeah, one character or one letter has been ended here. So to make it more robust and better, we also include a X, for example a number, which will be appended to the character representation, to the integer representation of the character. And yeah, after that we take the power of it. So we'll define the encode letter again. Define encode letter SX. It takes two arguments, a string and an integer, by which we want to increment it or add it. Math.power, and then we want to add X to the integer representation of the first character in the array S or sequence S, and then we add 2 to it as well. Unmatched delimiter. Yeah, I missed one. Yeah, that's what I don't like about this language for now. So we'll also add a pound symbol or whatever we can desire. For example, it could be star, etc., or add symbol, etc., whatever. We'll append it before our code. So there are 4 to end it. Nope. 1 2 3 4. 1 2 3 4. Oh yeah. And it should work now. Yeah, it's working. And let's change the encode function as well. So it takes this, it works with this newly defined encode letter, which takes 2 required arguments. So defn encode takes a single argument, and here we'll define let number of words, and number of words is defined by counting Clojure dot string split s, and count symbol, is this supposed to be a space? It doesn't seem like. Okay, and then we can use Clojure dot string slash replace s, count symbol, replace every character or every letter, call this function fns, encode letter, which takes number s and number of words 1 2 3 4. So how were we defining it before? Here we simply defined it Clojure dot string dot replace s with this with encode letter. Okay, yeah. Got it. Here we defined encode letter just like this, because this replace function replaced required a function, and it would pass s as an argument to it, or match parameter. For example, here we're getting only the first character, or here we're getting the character, so it would pass each and every character to encode letter. But we also want to pass the number of words as well, so here we're passing each and every word to this anonymous function. Here it's s, and then use that as to call encode letter with our number of words. Yes, I'm missing yeah. Now let's encode them again, and yeah, for the sake of comparison, I'll encode what they're encoding as well. Where's super secret? Why do we have different numbers? Shouldn't they be the same? Huh. 7225 super secret. Probably, yeah, I guess I should use a code editor to write this function easily. Let me quickly add these and allow access and close that. And before that, I think we should create a separate repo for us as well, so we can save our code there. Let me quickly, where's this little sign in here? Close folder. Is sign in. And just wait a minute. So 1.2278 verify. And we're in. Let's create a new repository. We'll call this Clojure workshop. Yep. Code for the Clojure workshop by git. Let's make it public. Add readme. Add git ignore Clojure, and choose a license. I'm fine with MIT license. And let's create this repository real quick, and we'll also clone it. There you go. So it will be in cd workspace git clone, and then we'll open it in our editor here, workspace, where is Clojure workshop, select folder, and I'll also move these two files which we did in a previous stream, activities, and move them into the folder as well. Your workshop, it was for chapter 1. Yeah, let's make it chapter 1. And I'll quickly git status git add git commit first chapter activities and git push. So I just want to see if everything is working correctly. Yep, seems to be working fine. We'll quickly create a new chapter as well, chapter 2, and here we'll write this exercise now. Okay, exercise 2.01, the obfuscation machine. Let's create a new file, e2.01, the obfuscation machine. Okay, I think we should do this instead, so we don't have to type in the works around this. Now we activate it. I wonder if it would work this time. It was working fine. Yeah, not okay. Let's forget about it for now, and we'll define our encode letter and encode functions here. For now I'll just copy paste this, and it's missing, yep, it's missing this. looks fine now, and we'll try to paste this. So yeah, there was a space here. That's what I was expecting. That's why it wasn't working, or their output wasn't same as mine. So now it should match bracket. Why do I keep missing this? And yeah, this is, I don't like this functionality. For example, here I'm pressing delete and it's deleting both of these. I just want the, and when I try to press backspace here, it's not. Yes, there must be some setting. Bracket highlight. Enable bracket color, highlight, misplaced bracket style, bracket spacing. Auto closing over type. We'll have to figure it out later. For now, I just have to select it manually and then press delete, which is not ideal. Anyways, so now if we call encode on super secret, it should result in the same thing, hopefully. But if there are multiple and yep, and it's 7225 and 13924. So yeah, it's working perfectly now. Yeah. For the encode function, we took the square of the character's ASCII representation, and for decoding we'll take the square root to reverse that. Okay, let's write the decode function. Here I'll define decode. Yeah, same as before. First we'll define decode letter, which would decode a single letter, and then we'll use that function in the decode function, which would decode the whole string. So decode letter, it would take two arguments, x and y. Here will, yeah, number, wait, what is the number? Decode function x and y, let number, yeah, number of words. X is the number. Nope, x is the string and y is the number of words, right? Because here we're defining number of words and then we're passing first s and then number of words. So this is s and this is number of words. So why not use s here, make it more clear. Yeah, I'd use s here, and y, instead of y I'll use n for number. So here let number is equal to integer, so we'll try to parse integer. Subs x1 okay, it's not s, it's s. So yeah, this would be passed. 7569 would be passed on here to this decode letter. It would try to parse it and convert it into an integer and call it the number. Okay, and what is the letter then? Letter. And letter is, yeah, letter is the conversion of this number. It would take the square root of this number, and for example here before we added some number to it, x to it, and now we'll subtract that number from it. Here it is y, we're referring to it as y, and here we're referring to it as n. So yeah, let's quickly do that. Number one is number and the other is letter, where we take the character representation, subtract from the square root of the number that we recently calculated, and subtract y from it, and not y but n, and then we'll simply return the string version of letter. Letter, unresolved symbol letter, unused finding letter. Yeah, I should do this inside. Yep, I think this would work. And then we'll define a decode function as well, which would be run over the whole string s, and we'll define the let block where number of words as calculated before would count. Clojure.string would first split the string s using, we can simply copy this. And then we can call replace on s, matching this sequence or this regular expression. So we're neglecting this, and d plus will probably be some integer digits, some number of digits, and then we'll pass this on to our anonymous function s, which would call decode letter, passing in the argument s and number of words. This should work fine now. Yep, yeah, let's hope it works. So if we call decode on encode album, it should work. I'll just copy paste it into the terminal, paste anyway, and yep, if we encode Adam and then try to decode it, it would return Adam. So it's working. And we've completed this obfuscation machine exercise. I wonder if there's a formatter for pretty and let me quickly search for a Clojure formatter. Clojure snippets, Clojure tool, linter, there's linter. I wonder if it would work with Clojure as well. Probably not. How about prettier? So language supported TypeScript, Flow, JSX, JSON, CSS. Your favorite language? Yeah, let's try to quickly see. PHP, Swift, XML, Java, packages on Clojure, VS Code, prettier. Elva does support code formatting, features syntax highlighting. So Java what if I do this? It's not really formatting Java. Nope. Yeah, it's not working as expected. Anyways, I'll figure it out later. So let's continue our journey.
In this exercise, we will use some basic string manipulation techniques to come up with a very basic obfuscate.
Okay, now we'll learn about booleans. Booleans are implemented at java.lang.boolean. If we know about all of these four symbols, keywords. Nothing new here. Yeah, we know about maps, sets, vectors, and lists already from the Clojure from the ground up chapter. We've learned about this already. Maps. Apparently there are two types: hash maps as well as sorted maps. Clojure supports hash maps and sorted maps as well. By default, it creates hash maps. Or we worked with hash maps before this. And if you don't know, for example, hash maps and dictionaries are the same. If you don't know, they support very fast lookup and insertion and deletion. We can create hash maps like this, and notice we first it's a key value pair. We provide a key and the value associated with it, then again another key and the value associated with that key, another key and the value associated with it, and between these semicolons or commas, sorry, the commas are optional. We can include them or not include them, doesn't really matter. Yeah, we can use comma as well. We can use comma or space to separate them, doesn't really matter. So here we're defining a key, David Botar, and assigning another map to it. And here the first, this is the key, and here we're assigning another map to it. So this is a map nested inside a map, nested inside a map. So you can define complex structures like this then. And we can also use the hash map function as well, just like for example in to define a vector we can do this or this. So or vector, sorry, vec is to convert another list to a vector. Only map keys should be unique. Here we're passing name 2 times, so an exception is thrown. Duplicate key, they shouldn't be duplicated. Okay, so another exercise. Yeah, I love this approach better. Clojure from the ground up, it was all just text. Here we're really programming and creating yeah, let's use REPL for this. We don't need to create another file. So let's create a map. We'll define it globally. Favorite fruit name mango. Yeah, let's just, for the sake of comparison, let's just go with what's written there. Green K calorie per 100 G is 61, and distinguish mark is 80. Let's close this and close the def. And now we can access it. I wish it supported auto completion. Favorite, it's, yeah. Okay, we can read using get. Yeah, we know that already. Favorite fruit, we can get a name. We can also do this, favorite fruit kiwi, or we can do this as well, name favorite fruit kiwi. We know about these things from a previous chapter in the Clojure from the ground up. And we can also provide a default value as well. Here, for example, if something isn't present, it would return nil, but if we provide a default value, then it would, instead of returning nil, it would return that default value if it's not present. Yeah, here we use this like here. Provide a fallback value for a key that doesn't exist in the favorite fruit. Okay, so for example, here shape doesn't exist in the favorite fruit, then we can also provide a default value like this. Okay, does it work either way? Favorite fruit, let's return en. Yep, works like so. And then favorite fruit and en. Yep, it works. Okay, to add another value, we can use the associate a new key shape with value egg-like to favorite fruit. It would add it. Okay, so add to the favorite fruit a new value called shape, and we'll call this egg list, not list. And yeah, it's added egg-like. Okay, so if we try to access it, it hasn't changed. Map is immutable. Yep. Create a new version of the map. Now the F3C funny fruity fruits consortium have reverted their previous ruling and it. Okay, so a sock returns a new map but doesn't update the original one. Now we've learned about this before, that all data structures in Clojure are immutable, or I guess most of them, not all, we're not sure. Favorite fruit color, let's change it to brown. Let's yep, so I forgot the what do you call it? This is a single quote, double quote. Yeah, double quote. Favorite fruit color, let's make it brown. And oh my bad, we're outside the Clojure apple, and we'll have to, yeah, let's quickly create this, and then we'll do this. The value brown is updated here, but if we try to call, I should have typed something that's shorter. The original value isn't changed, the one we bound to favorite fruit symbol. So if you want to, update the original one, I guess we'll have to def favorite fruit and use the returned value by a sock. Now we can add, for example, another map inside one as well. A sock, favorite food, kilogram, okay, and where. Getting the value of kilogram per 100 gram in the favorite food and decrementing it by 1. Okay, so we can use the update function instead of doing this, a sock, and then getting the value and performing the decrement operation on that. We can instead use update on the favorite fruit, get the on what key. For example, to get a key, it would return a value, and then we could perform dec operation on it or decrement operation on it. So this would return a kilogram per hour 60. Before it was 61, I think. Yeah, 61. It would decrement it by 1. Okay, yep. Here we're calling the subtract function and providing it the value 10. So is a sock, and dissociate